Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge. The lowest common ancestor of binary tree. Given a binary tree, find the lowest common ancestor of LCA of two given nodes in the tree. According to the definition of LCA, we have to check with Wikipedia, but the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. So where we allow a node to be a descendant of itself. So for this, if I say the lowest common ancestor for 6 and 2, it is nothing but 5, because the ancestor of 6 is 5 and the ancestor of 2 is also 5. Where if I say where the 3 is also the ancestor of 6 and 2, but we want to find the lowest common ancestor, which is nothing but this is 5. If I want to say the lowest common ancestor for 6 and 0, if I want to say the lowest common ancestor for 6 and 0, we can say the lowest common LCA is 3. So if we want to say find the lowest common ancestor for 6 and 4, it is 5. For lowest common ancestor for 6 and 5 is 5 itself. So what we come to observe is we have to find the LCA of two given nodes P and Q. For this example, they have said to find the lowest common ancestor for 1 and 5, where for 1 and 5, which 3 is the LCA. So according to this observation, how we can find the lowest common ancestor is, we can find in one approach, which is brute force approach, which is nothing but we can find the path from root to node P and path from root to node Q. Once you find the path, let us find the path. So from the root to P, what will be the path? P is nothing but 5. So what is the root to, what is the path for root to 5, which is nothing but 3 comma 5. Then what is the root path between root to Q node? Q node is nothing but 1, which is 3 comma 1. So if we find the path between the two nodes P and Q from root, then we can traverse the whole array, and where we found the two elements not equal, the previous element is nothing but our LCA. We can take some other example. Consider the consider P as 6 and Q as 4. So what will be the LCA of our Q 6 and 4? So we will find the root to 6 path, which is nothing but 3, 5 and 6. And what will be the path from root to 4, where it is nothing but 3, then 5, then 2, then 4. So this is our path for respective P and Q nodes. So when we have the paths generated, we have to traverse these paths simultaneously, and such that we can see that 3 is equal, and we can see this 5 is also equal, but you can see this 6 and 2 is not equal. So we can say the previous node, which is nothing but the 5 is our LCA. So this is one way of finding LCA of two given nodes. That is nothing but the brute force approach. For this, what will be the time complexity for this approach? What will be the time complexity for this approach? First, we have to traverse once to find the path of root to P. So that may take order of n, and we may need another order of n to find the path from root to Q. That is an order of n. And then we will be needing a traversal of this entire vector until we find our LCA. That may require an order of n. So this so approximately after it boils down to order of n time complexity. And what will be your space complexity? Space complexity is nothing but the order of n 2 into order of n. So it is extra using an extra space. So how can we optimize this approach? So this is our brute force approach. How can we optimize this approach? We can use a recursive approach to find this. We can see this is a binary tree, and there are only two paths possible, either left or right. So if we want to consider LCA, if we want to find an LCA of 6 and 4, what we can say is we can go each of the sides, both left and right. Whenever we found a node which is either p or q, then we will just return node. Else we will what we will do is we will return null. So if we find the first starting point where we find the two nodes from left and right, we get a not null nodes, then that starting point is nothing but our LCA. That is, we can traverse 3's left, and for 6 and 4 is not equal to 5, so we will be traversing its left, and this node is equal to either p or q, which is p, it is 6, so it is equal to 6. So we will be returning 6 to this fifth node. Then we will be traversing to its right. So we have reached 2, and then we will be traversing to its left. We have reached this 7. Then we will be traversing to its left. It is null. So since it is a leaf node and this is not equal to P or Q, so we will be returning a null for this node. And then we will be traversing to its right, and to its right we have found that this node is equal to q, which is 4. So we will be returning this 4 returning the node 4 itself to this root. So now we are at 2, we are having a 4, and we are having a not null node here, so we will be returning this not null node to our node. So once we found two not null nodes, which is from this side we have found a 6, and from this side we have found a 4, and this point is the starting point where we found two non-null nodes from its left and right. So this is the point where we found the LCA, and this node is nothing but the LCA of this 6 and 4. So this is how we will be finding the LCA for this node, for this problem. So let us go for this approach and code, so that it will be more clear. So what we will be saying is, if my root is null, just return me root. Then if my root is not null, then my root of val, if my root of val is equal to if my root is equal to p, or if my root is equal to q, then what I can do is I can just return root. Since I have got one node which is p or q. If I'm not having this both the case, then I have to go left as well as right. So what I will be doing is, first I will be going to its left, and I will be calling this lowest common ancestor function itself. So first I will be going to its left, root of left and p and q. I will be passing to its function. Then I will be calling this tree node lowest common ancestor for its right, root of right, p and q. Now once we have figured it out their left and right, what we have to check is we have to check whether we have both left and right as not null. If my left is also not null and my right is also not null, that is, if my left is also present and my right is also present, then what I can say is just return me root, which is nothing but this current root is my LCA. Or else what I can say is, if my left is null, then I will be returning its right. Else I can just return my left itself. Since left is not null, then I can just return my left itself. So this is how we can write the LCA code. Let us run the code and see. So now let us run our code. So it got accepted. Let us submit the code. So what will be the time complexity for this approach? The time complexity is order of n, since we are we are traversing the whole binary tree only once. And what will be space complexity? It may reach up to order of n. If it is a skew tree, it will be having an auxiliary stack space. So this is our today's LeetCode daily challenge, and hope you understand this problem. If not, go back and see once again and let me know in comments if there is any suggestions. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.